Is this working? Is this working? Let me see. I don't think this is working. This is working. If anybody sees me, just type in some message in the chat. I see one viewer. Welcome, 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 welcome. And one like, nice. And one like, nice. Can you join? Can you join? Let me know if you can see me. Let me know if you can see me. Guys, can you see me? Guys, can you see me? Let me. First time I'm using this. First time I'm using this. Let me just move the OBS here. The OBS here. Do you see the PDF here? You are echoing. You are echoing. Okay, just a sec. Let me fix that. Let me see what's going on. Let me see what's going on. Settings, audio. Just bear with me. Just bear with me. I know I'm echoing. Let me just see how I can fix it. If anybody has an idea, I'm streaming this via OBS. Basically, I don't see any settings here. Where is my mic picked up? Just a sec. Just a sec. Streaming settings. Is it terrible? The sound? Or is it just a minor echo? Let me just see. Fuck my life. Can I curse on the streams? Customization. I don't see settings anywhere. Let me just move this screen here. So maybe somebody can help me. So, if we go to settings, audio. Where is the default chosen? Here? What's this? Monitoring device. Trying to fix it. Anybody has a clue how to do this? Let me just Google it. This is gonna be a long stream, by the way. So I'm gonna go through the paper. Multiple hour stream. So bear with me. You can put this on the side. While I'm setting up the audio. Input to set OBS streaming. Okay. Just a sec. Let me disable this one. Yes. Is it better now, guys? Is it working now? Do you hear me nice? Is it working? I don't see it sending the messages. Still the same, right? Okay. Just a second. Properties. Audio device. Okay. Do you hear me now? Is it still echo? I'm trying to disable because I have these headphones here and I have my Sony ZV that's filming me here. Just trying to see where it's picking up the sound from. There's gonna be a lot of fun moments like this where we're just debugging stuff over the next weeks and days. So get used to it, I guess. It's just a second. It is good now. Okay. It's good, like the sound is decent, or good, like, because it might be picking up the sound from here. It works. Oh, hi, Amrit, what's up? Amrit joined, I see. How many people do we have on the stream right now? Let me see. 12 people. Okay, I still didn't share this with anyone, so that's cool. Let me just make sure first everything is working, and then we're gonna invite more people, and then we're gonna start. So it's a long paper, 100 pages or something, and we're gonna literally go through the whole thing. That's the plan. It's gonna be very slow. It's gonna take us a couple of hours to go through the paper. I'm not gonna do the usual summarizations like on YouTube. It's gonna be much more in depth and basically go through the whole thing, and then later go through the code base. It's not ASMR quality, but it works. Okay, fair enough. Just a second. I think I might make it better, and I think it might be worth it just because you'll be bearing with me here for a longer time. Let me just see. So if I go here, this guy is not recording the audio. This guy is. If I go to properties, okay, configure video, that's fine. Just a second. Capture audio only. Okay. And then if I use custom, I know this is gonna fuck it up. Just give me a second. Maybe I can try plugging off this guy. Is it echoing? Is it echoing now? Again, or is it better? What a start of a stream. Technical issues. That's gonna be the leitmotif of this whole streaming series. Stuff not working. Why is it not working? Echo. Oh, fuck my life. Okay. Then I think I have one more option. I'm gonna plug in a professional mic. I think that might be good. So I have this guy here. I'm just gonna plug it into the camera here and remove my headphones. I think that's gonna be the best thing. Give me a sec. Okay, let's see. Just a second. Can you hear me at all? Let's see how this works now. Years. What are you guys even doing with your life? Watching me debug the audio issues, not even terrible. She says, okay, thank you. That's beautiful. It has a lot of noise. And now? My God. Still?
test, test, test. Why is this mic not working? It should work. We can hear the digital dragon. Okay, that's my machine learning rig. So you can hear the humming. Just wait a sec. Does anything change if I do it like this? Aha, and I think it's only mono. I can hear it on my left speaker. Okay, guys, this is terrible. I'll have to... Okay, just a sec. I'm curious whether you hear me. Do you still hear me? I might just be using the Sony ZV-1 mic. Go back to the one we said was okay. Is it okay now? Can somebody confirm if you can hear me now? If not, yes. Is it acceptable? Okay, I think we can get started. Awesome. I think we can get started. I can fix the sound over the next couple of days. First day, we're gonna do this. I'm planning on doing this every day over the next days. So, welcome everyone. Yes, we can hear you. Okay, awesome. Little bit increase if possible. Huh, can you try increasing it on your side? Because I don't think... Is it louder now? Like I'm trying to figure out whether it's... If I'm getting... Because the situation with my audio on this system is horrible. I have some audio somewhere like on my monitors or something, and then I have the camera here. So I'm not sure where it's picking it up. So I assume... Is it loud now? If you can increase a bit would be perfect. Okay. I don't know how. That's the problem. Let's see. Maybe in OBS. If I go here, mic is already maxed out here. Okay. It looks like it's maxed out. Lock volume and hide rename, filters, properties, device. Huh, maybe, wait. Let's try this. Any difference now in the sound? It's great. It's working perfectly. Okay, I think you guys are just like pissed off waiting and are now just saying it's working. Let me, maybe, okay, I think this should be good. I see two audios here. Hopefully only this one is picking up. It looks like only this one is picking up. Okay, awesome. So I'm gonna invite more people now. And let me just explain you how this is gonna look like basically. So I'll be streaming until 5 p.m. today probably. I'll basically be doing stuff that I'm doing when I'm alone and not streaming myself like a weirdo. So I'll basically just be reading this and you go like alongside me. It's not gonna be as curated as when we have it on YouTube, obviously. And today we're gonna go through the SeamlessM4T paper. So this massively multilingual and multimodal machine translation paper that just came from Meta. And then later we're gonna go through the actual code base. So that's the idea. So that's why it's gonna take at least until 5 p.m. I have hard stop at 5:30, so I'll have to drop then. So don't expect this to be something super quick, short stream, just FYI. Okay, let me just invite folks from the Discord if anybody wants to join. By the way, feel free to share with anyone you think might find this useful and interesting. And the bigger idea of these streams is going to be basically to replicate the work from Meta. Basically, you guys know that they released this no language left behind model, but it's not truly open source. It's actually this non-commercial Creative Commons license. So what I'm going to try and do is, I guess we'll have to start with data, but the idea will be to replicate the model and make it fully open source so that you can use it for commercial purposes. And that's basically a TLDR. Just give me a second. But it's going to be fun. Going to Discord. Let me show it here. You guys only see the single screen, right? Let me tag everyone. It's gonna be fun. Guys, I'll be streaming the whole day today until 5 p.m. CT. At least that's the plan. Over the SeamlessM4T paper and later codebase. The broader vision of the streaming series will be to film the process behind replicating the NLLB project from Meta and make it truly open source. Guys, to come and contribute once I create the actual code base. Okay. The whole day today until 5 p.m. at least that's the plan. Series will be to film the process behind replicating the NLLB and make it truly open source. Okay. I'm not sure. Did you guys get the ping? For those of you who are in the server, just let me know if you got the notification. I'm not sure whether I disabled this over the last couple of months because otherwise we'd have too much spam. If anybody can confirm it. You got the notification. Okay, Sarah said that you got the notification. Okay. Let's go. So I also assume you got the notification on YouTube. So let me just quickly write a post on LinkedIn. And by the way, it would be super cool if once the video is uploaded, we could just clip out the initial part with audio. I don't want people looking at 15 minutes of me not doing anything smart. But these streams are going to be long, as I said, so it's impossible to make them curated. And this is the first time for me I'm doing something like this, so bear with me. I guess I'll become better with time. Okay. I'm going to paste this. Just a second. You're seeing everything. You're seeing the marketing as well. Ah, my God. Just a second. Actually, have a description for YouTube here. I'm gonna try something that probably hasn't been done before, probably for a good reason. Nobody has done this before. Over the next period, I'll be daily streaming replication of Meta's NLLB project, making it fully open source. It's gonna be fun. I'll regret this sentence. I know it. This time, though, it's gonna be different. This is not a solo project, as I already said. And I encourage anyone passionate about this to join and contribute. I'll soon create a dedicated repo as well. And in today's stream, we'll be reading the recent SeamlessM4T paper, and later I'll go through the code base. Let me just link the actual paper, SeamlessM4T paper. Here it is. Why is Meta not publishing their work on our archive? Is there an archive link? Or I'll just link this thing here. Okay. Let me try and have the chat. I don't see the chat anymore. Can I take this thing and move it somewhere or not? Let me just move it here. Okay. 17 people. Welcome everyone. First draft. Yes, Smith. Not even the first draft. I literally just, well, it is a first draft. I mean, I'm just gonna post it as it is basically. Let me maybe add like a clickbaity thumbnail. Those are the link the video. Okay, that's a good point. That's a good point. Just a second. Okay. Here's the thumbnail. Replicating Meta NLLB, and my favorite thumbnail ever. I'm just reusing this one so badly because I'm so lazy to create new thumbnails. Okay. Let's see whether this makes sense. I'm going to try something that probably hasn't been done before. Over the next period, I'll be daily streaming the replication of metas. Let me tag Meta. Maybe they decide to open source it after they see the tag. Making fully open source is gonna be fun. Different. It's not a sole project. I encourage anyone passionate about this to join and contribute. Hope this goes well. Thanks, Luca. I also hope it goes well. In today's stream, I'll be first reading the recent paper and later I'll go through the code base. Okay. And finally, the YouTube link for the stream. Can someone paste the link? Where can I find my own link? Let's let's go to my channel. Okay. Is this it? And finally, the YouTube link for the stream. Okay, I see something. Can someone paste the link? We are live, guys. Where can I find my own link? Let's let's go to my channel. Okay. Okay. Is this it? That should be it. Finally, the YouTube link for the stream. Okay. LinkedIn might bring us a bit more people. 21 people right now. I'm gonna also repost this just to Twitter, and we can slowly start going. Okay. I hate because LinkedIn always has these shortened links. Okay. This is basically gonna be like a study group, like study with me group or something. If you're familiar with that concept, as far as I know, it's more popular in the East. Shortened links. Okay. Let me just add. Okay. This is basically gonna be like a study group, like study with me group or something. If you're familiar with that concept, as far as I know, it's more popular in the just try and get to the latest links. You're probably watching the older part of the stream. Okay. I'm not completely sure how that looks like. It's basically gonna be So here is the link here. Let me just link study with me or something. Put the thumbnail here. Familiar with that concept? As far as I know, it's more popular in the just try and get to the latest fully, but truly open source. Okay, I had probably watching the older part of the stream. I'm not completely sure how that looks like. Basically gonna be. So here is the link here. Let me just link study with me or something. Put the thumbnail here. Okay. Familiar with that concept? As far as I know, it's more popular in the just try and get to the latest fully, but truly open source. Okay, I had probably watching. The best thing about this whole thing is I never actually watched anybody stream other than maybe George Hutz, but like those were not live streams, so I have no idea how this is supposed to be. So that means thinking from the first principles. Ignoring LinkedIn notifications here. Truly open source. Okay. Going back to the paper. The best thing about this whole thing is I never actually watched anybody stream other than maybe George Hutz, but like those were not live streams. Is this legal? Wait, guys. Can you hear me? Okay, now. Entangled stream. Inception stream. You have the stream open on your end and we can hear it playing back. Fuck. Sorry about that. What about now? I should have stopped it. Waiting for latency. Okay. Okay. Is it good? Good now, thank you. Okay. Nice. Let me just see how many people are here. So we have 22 people. Nice. Guys, bear with me. Let's slowly start digging into this. Let me just see whether people saw the messages on Discord. Shrishti in the general channel asked, when do you start? Well, I already started, but it's going to be recorded for those of you who want to check it out later. Okay. Let me see whether I posted everything nicely. Just a second, bear with me. Okay. Looking good. So that's Twitter, LinkedIn, YouTube, and Discord. Why don't I see the... I want just one thing. I want to see the... I should see the chat here in OBS, but I don't see it. Oh, here it is. Can you guys see the chat as well now? I can put it maybe up here or something. Tell us about your startup. Well, my startup is just getting started. This paper is the start of my startup. It's Ortus AI. It's I'm basically going to be replicating this work and then just be playful, to be honest, and then see how it goes. It's more about the process. I want to find something that's economically valuable, interesting for me, somewhere where I'm good at. So this is kind of that experiment in a way. Tell us a cool fact. I see a lot of Serbs here. Mirko, ciao Mirko. Nice, Luka and Mirko are there. Tell us a cool fact. A cool fact. What could be a cool fact? Maybe if you didn't know, GPT-4 apparently has 1.8 trillion parameters. That's the first fact that popped onto my mind. Okay. Guys, I think we can start. So somebody says, be careful. It does mean that if you write from scratch a model, then it it is for commercial use. Why would that be the case? I mean, it depends ultimately on me, on whether I want to open source it or not, and the whole community, and the license is going to be open source. So Apache 2.0 or MIT, I'm not sure still what makes more sense. The cheat code for such cool facts is you can always say you yourself are cool. No, that's that's probably the least cool thing you can say about yourself. Guys, on YouTube, you're watching this on YouTube, I assume. Do you see double, like if I put this thingy here, like will you see two chats, I assume? One in the actual GUI of YouTube and the second one on the screen? If so, I'm just gonna move this outside. I guess I'm a complete noob for streaming, as you can tell. I don't know the basics, but you're gonna see me learn over the next period. That's something I'm excited about. Okay. It's 1 p.m. Let's get started. SeamlessM4T massively multilingual and multimodal machine translation. Okay, I think you might be lagging behind me a bit because I asked that question like 30 seconds ago. See whether you're following the stream as it goes. Maybe you're lagging behind. What will you be using to build this? That's a good question. Well, the original code base is in FairSec, so NLLB is in FairSec. This paper here is built in FairSec 2.0, so that's their new version of the framework. I think that's their plan actually made a. Let me show you this. SeamlessM4T. Let's go to GitHub. If we go to issues, I think, no, sorry, actually, FairSec 2 GitHub, I opened up an issue and they replied saying they are planning to deprecate the old FairSec. So here's my question there. And somebody from Meta replied, so I asked, does this mean you're deprecating FairSec? Somebody replied, not right now, but eventually we plan to phase out deprecate FairSec once we have full parity in FairSec 2. We don't have a specific timeline, but expect it to happen sometime in 2024. So we'll see. There are plenty of options. We can also use GPT-NewX. I think that might make more sense because people from the open source community are more familiar with GPT-NewX than with FairSec. That's just normal streaming latency, says Luca, don't worry about it too much. Okay. And start kind of going through the paper. You can go with me here. I'm not gonna read everything out loud, obviously, because otherwise I'll lose my voice until page 10, and there is 100 pages. So let's kind of slowly start exploring this. I'm gonna behave as when I'm studying on my own, basically. Okay. What does it take to create the Babelfish? Okay, Babelfish is this basically like old idea of trying to create a universal translator. And obviously the idea of this paper is, just for a quick context. So basically the idea is to be able to translate from text to audio, and then translate from audio to audio, and translate from audio to text again, and from text to text. So like all four possible directions, thus creating the kind of universal translator. Although depending on those four components, whether you're translating from language to language or text to text, I think they support like 30 languages for when you're translating between speech and speech, and only actually 100 languages for text to text. Not only, but like, so only 30 for speech to speech. But we're gonna see those details in the paper. Okay, let's jump into it. Tool can help individuals. So this is the NLLB project. That one went over 200 languages. 202 if I remember correctly. Okay, so they introduced the SeamlessM4T, a single model that supports speech-to-speech translation, speech-to-text, as I said, text-to-speech, text-to-text translation, and automatic speech recognition for up to 100 languages. So the difference between automatic speech recognition and translation is, in translation you're going from different human languages to different human languages. For ASR, you basically just transcribe whatever is the original language in the audio. Welcome, Giampero. I might, guys, those of you who are in the chat, maybe for people who pop in, just give them some brief context. I would super appreciate that while I'm going through the paper. So they used 1 million, this is important, they used 1 million hours of open speech audio data. That's a lot of data. I think that Whisper even used maybe 400,000. Let's quickly check that. Let's make this a bit more interactive. So like Whisper paper, if we open up the paper here, let's see whether they mentioned, okay, so they say when scaled to 680,000 hours of multilingual and multitask supervision, the model general is well. So that was Whisper, and Whisper already went kind of 10x above all of the previous work. And here we have even more hours of audio to learn the self-supervised speech representations with, I guess this is Word2Vec, I'm not sure what this is. Subsequently, we created a multimodal corpus of automatically aligned speech translations dubbed SeamlessAlign. This is going to be important. So basically, the dataset is the name of the game. If you have high quality data and if you have compute, the models want to learn. I think Elias Itzkever said something similar. Like it's these models, like if you just, obviously you have to set the correct hyperparameters, but if you have the data, if you have the compute, you have the power. Let me just save this. Just a sec. Where did I save this? I think here. Okay. I'll be just highlighting some important parts here. Filtered and combined with human labeled and pseudo labeled data, we developed the first multilingual system capable of translating from and into English for both speech and text. Okay. On FLIRS, this model sets a new standard for translations into multiple languages, achieving an improvement of 20% BLUE, which is a machine translation metric. That's kind of not the best one. It's not semantic in nature. It basically just does some n-gram overlap calculation, and so it doesn't always correspond perfectly with what humans actually care about. But it's the best thing we've got. There's a couple other new neural metrics that Google proposed actually over the previous period. I don't remember the exact name. I'd have to Google it. No pun intended. Over the previous. Okay, compared to strong cascaded, improves the quality of into English translation by 1.3 BLUE points in speech to text and by 2.6 ASR BLUE. This on CVSS and compared to a two-stage cascaded model for speech-to-speech translation. SeamlessM4T large performance is stronger by 58%. This currently just sounds like a bunch of marketing speech. I don't think you can, I'm not sure how well 1.3 BLUE points translates into something that humans can notice. So I'm more interested in hearing about human evaluations. Okay, they say here preliminary human evals of speech to text outputs evidence similarly impressive results for translation from English. XSTS scores, those are some, I guess, something similar to like MOS or something, like those human scores. For 24 languages are consistently above 4 out of 5. Okay, I'm more curious about like relative comparisons here, to be honest, than absolute. So it's apparently better than Whisper Large V2, which is the biggest model from Whisper, for 7 out of 24 languages. To further evaluate our system, we developed Blazor 2. This is going to be interesting. This is the system they use to, I think, mine the audio data, similarly to how they used Laser. So they basically have this Laser model that helps you mine for parallel corpuses. So what's the thing? There is plenty of data that's like monolingual on the internet, but like what you want to have is a parallel corpus. You want to have a sentence corresponding to its translation, direct translation in your target language, and it's hard to find high quality data sets of that nature, especially if you go away from English, if you go to some so-called lower resource languages. And so what mining does is basically what you do is you embed, you take the corpus in one language, say English, you take the corpus in a different language, say like German, and you can maybe take the data from Wikipedia or whatnot, you embed it into these special models, and then in the embedding space, you basically try and find, for an English point in the embedding space, you try and find neighboring points from the different language, for example, German, and then those are your potential translation candidates. So you're kind of pseudo labeling your data set, you're finding you're mining the translation, that's why it's called mining, in order to get the parallel corpus that you need in order to train these machine translation systems. And so for Blazor here, I guess it's going to be similar logic where they're just going to do the same thing just for audio. They'll have to embed the audio files into the embedding space of some of these models, and then they're going to do the search. And this search is augmented obviously by some vector databases like VV8, etc. So you'll have to have such an index. It's fairly intensive, so oftentimes you have to also shard these indices across multiple machines. It's a distributed problem. It takes a lot of compute, but it's ultimately very fun. Do you guys still hear me? Let me just see in the stream. I see 20 people in the stream. I'm not sure how much I'm lagging behind. Which enables evaluation across speech and text with similar accuracy compared to its predecessor when it comes to quality estimation. Tested for robustness, our system performs better against background noises and speaker variations in speech-to-text tasks, blah, 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 compared to the current state-of-the-art model. Okay. Critically, we evaluated Seamless on gender bias and added toxicity to assess translation safety. Okay, awesome, guys. Thank you. Compared to the state-of-the-art, we report up to 63% of reduction in toxicity. Blah, blah, blah. Finally, our contribution is work, including models, inference code, fine-tuning receipts backed by our improved modeling toolkit. So there is the FairSec here, version 2, and metadata to recreate the unfiltered 470,000 hours of seamless align. So I guess something we can try and do is, because that thing is open source, we can try and recreate the actual data set. And that's ultimately going to be the first point, because I think they either didn't release the data set, or if they did, the license is not a permissive one, so we won't be able to use that to train the open source models. Okay, so they say all that is accessible. Well, Meta loves using the word open source. This word is losing its meaning over the past months and years. Because it's not truly open source, they always have some additional statements and stuff. Okay, let's start going through it. Introduction. The Hitchhiker's Guide to Get to the Galaxy's Pebbles Fish Strike. Let's read this, each of us for ourselves. I'm gonna just pick out interesting parts. Okay, it's just usual marketing speech in these introductions of big papers that have like, this one has like 100 pages or something. Basically, everybody knows you want to create a universal translator. I'm actually very bullish myself on this, because like when I was a kid back in high school, I started learning languages, and I learned most of them back then because later during the faculty I couldn't really study. I didn't have the time to study languages, so I learned 5 languages in total back then, basically. After you learn 2 foreign languages, the third one, the fourth one, it starts becoming so easy. And that's why, like, when I see somebody bragging they speak like 10, 15 languages, I'm not that impressed. I know it took a lot of work, but like, if you can speak 6, 7, 5, it already means you have everything you need to pick up another language fairly quickly. But it's ultimately very important, and these systems are important in my opinion just because ultimately the whole internet is currently biased to just use English. All of these languages are just focusing on all of these large language models, and other ML models are focusing purely on English. And like, I think it's very important to obviously preserve the culture and the language of each of the countries around this world. And a system like this allows us to do this type of real-time translation ideally, so that you won't be forced to learn English necessarily. And like a lot of us, including me, we use a lot of English words even when we speak our native language. So because of that, I think this idea makes a lot of sense. It's very important. Okay, despite the centrality of speech in everyday communication, machine translation systems today remain text-centric. True, that's the NLLB model. Speech support, if and when present, is often seen. By the way, why am I doing this? I have an idea. Let me just open my OneNote for a second, and it's going to be easier to zoom in and show you stuff. Just a second. Add a page. Let me just insert this paper into OneNote. Okay. Let's see if this works. It's a long paper, so it's taking a bit longer. Okay. Here it is. Let me just see. Why did it disappear? Let me know if you can see the new OneNote. Let me just move this a bit further to the right. Okay. It's still blurry. Just a second. Okay. Guys, can you see OneNote now? Anyone? Awesome. Okay. Let's start. Let's continue, I mean. So we were somewhere here. Let me just see. Yeah, we finished the first paragraph of this page. Okay. So despite the centrality of speech in everyday communication, machine translation remain text-centric, as we said. Speech support, if and when present, is often seen as cursory to its text-based counterpart. So they mentioned the NLLB, they cover over 200 languages, but like the speech is lagging. So these are far from achieving similar scope of performance. Okay. Okay, the very challenge around why speech is harder to tackle from an empty standpoint, that it encodes more information than expressive components, is also why it is superior at conveying intent and forging stronger social bonds between interlocutors. Okay, basically, well, yeah, but also the file sizes are much bigger. The data set is going to be so much bigger than just purely textual. Okay, got it. I see your Sarah's comment there. Bringing the Babelfish into technical reality hinges on developing foundational speech-to-speech translation systems. Today, existing systems. So they focus on, as I said, on high resource languages, leaving many low resource languages behind. And so that's what the NLLB project tried to tackle. They focused on many of the lower resource languages compared to English and German and Spanish. Okay, and they mostly allow translating into English. I'm not familiar. I mean, all of the commercial offerings like Google Translate and DeepL, they offer both directions, obviously. Because for most people, you actually want to translate from English into their language, right? Because you want to understand something that's in English and you want to read it in your native language as opposed to translating into English. That's again English-centric. And here we want to be a bit less English-centric and a bit more focused on other languages. Okay, and systems so far have been mostly a cascade of multiple systems. Nobody trained these systems to be like a single system that's being learned. Instead, they say here it's composed of multiple subsystems. So S2ST stands for speech-to-speech translation. And they say you first have to do ASR. And then, so that means go from speech to text. Then do T to TT, which is text-to-text translation. So that means translate, now that you're in the textual domain, translate into your target language, and then do the TTS to get to the actual synthesis in the target language. And then there were some end-to-end speech systems later, okay. But they don't match the performance of these cascaded systems. Yeah, so for example, you could use Whisper to do ASR, and then you could do, so that means go from audio to text using Whisper, and then just use NLLB to translate into language, and then use some TTS, like, I don't know, either some commercial offering, like I don't know, 11 Labs, or like something like Suno AI's Bark, or like Tortoise TTS or whatnot. There is a lot of offerings to do TTS, both open source as well as commercial. So they introduced the system, which offers all of these capabilities, as I said, and to build this, we used 1 million hours of open source, open speech audio data to learn the self-supervised speech representations with this model. I guess I'm going to see what this exactly is. So they mentioned again the seamless align. We then combine a filter subset of this corpus with human labeled and pseudo labeled data, totaling 406,000 hours. Okay. Drawing on this assembled dataset, we developed the first multitasking system that performs S2ST from 100 languages to English and from English to 35 languages. Okay. As you can see, depending on the component, you won't have 100 languages. English obviously always has advantage. So apparently they outperformed the latest state-of-the-art model, which is the AudioPalm 28B AST, I guess a work from Google. Just looking at Palm model here, by 4.2 blue points on Fluorus. And Fluorus is this Facebook dataset, basically. It's like Facebook low resource eval or something. That's what it stands for. Let me just quickly, let me Google it. So Fluorus dataset, few shot learning evaluation, almost there. Almost there. There is one different one that actually stands for, like, I think it was Fluorus data set. I probably mixed up those two. Yeah, this one is Fluorus is Facebook low resource, and this is few-shot learning eval of universal representation. Either how is just like one of the Facebook's data sets for that's like massively parallel corpus. Compared to cascaded systems, improves translation accuracy by over 2 points. Okay. Okay, I'm not sure what CVSS is, but like just some data set, and they outperform basically these two-stage cascaded systems. Whisper for plus your TTS, which is the text-to-speech system, by a large margin, 50% improvement. Okay, they're just like now saying, hey, we outperformed all similar models. We see significant improvement of Whisper large baseline for 7 out of 24 languages. Okay, not as interesting. We're gonna forget a bunch of these details. Apparently they just claim that they are comparable to all of these systems, and well, they outperform previous baselines. Here is just some dictionary of what these terms mean. Hopefully I already explained what they mean. So X to T means X being an element from this set, either speech or text. To text, okay. Makes sense. Task XX, a translation task on non-English, English-centric direction. Got it. Let's continue, guys. So, let me just drink some water. Okay. Ah, nice. So they're actually better than NLLB 3.3b. So this sentence here, when evaluating T to machine translation, when they do that, the model matches the performance of the NLLB 3.3b dense model when translating into English, and improves by 1 point. I don't know how to pronounce this metric. CHRF++, very hard. On average when translating from English. So both into English and from English, they outperform the 3.3b checkpoint. That's cool, although that's not the best NLLB model that's out there. The best one is actually the mixture of experts model that has 54 billion parameters. Aha, okay, I made a mistake. This Blazor thingy is actually a language and modality agnostic evaluation metric for text or speech translation. Yeah, they have some different system for the mining process I explained. So Blazor 2.0 enables evaluation across speech and text modalities with similar accuracy as predecessor Blazor. Okay, we also evaluated model robustness against background noises. More robust than Whisper against background noise and speaker variations, with an average improvement of 38% and 49% respectively. When they say respectively, they mean, I guess, floors. Okay, awesome. Here are some of the baselines. We're gonna check out the table in a second. Let's see what else is here. Regarding responsible AI, we focused on adding toxicity evaluations. I'm not going to focus too much on gender studies and toxicity studies, even though that's important. I want to focus on the capability research. Okay, let's see here. To spur further research in speech translation and to make our work available to the community, we open source. The famous open sourcing of code, and so to be like quite frank, Meta did open source the code base for the previous project. So that means they had MIT license for the actual NLLB project, but the models and the checkpoints and the data, none of that was open sourced. And that means you have to have a cluster of 100 plus GPUs to actually build these systems. I think their biggest checkpoint, their biggest model, the 54 billion one, was trained on like 64 GPUs at least. I don't remember exactly, but I think something like that. Obviously, you need a bigger cluster because you want to do experiments in parallel. Okay, so they release a couple of checkpoints, the 2.3 billion parameter checkpoint and the medium. So that's the large, and the medium one is 1.2 billion, okay? As well as their inference code. I think what I'm gonna do is I'm gonna switch to PDF because I'll be able to highlight these things, and then once we need the drawing board, I'll switch to my OneNote. So let's just kind of highlight these portions. Tools for creating aligned speech data, including metadata to recreate the unfiltered, seamless align. So there is this Stopes repo that they also use for NLLB. It basically allows you to filter and post-process your data. Fairly good. Nice code. There is a link down there. Okay, so Sonar is the actual model I was mentioning. So that's the speech encoder for 37 languages and text encoders in 200 languages. Okay, so it's basically a system that encodes both the language and text, if I understood them well here. Okay, and they have the Blazor 2.0, the automatic evaluation model. Okay, and they include the weights and they include the inference scripts, although I assume we'll have to recreate the weights from scratch. Hopefully stability gives us some compute. We'll see how that goes. The rest of this article is structured as follows. Section 2 describes the socio-technical dimensions of the multimodal translation and motivates why speech is an important modality to tackle in the context of MT research. MT stands for machine translation. It also includes the list of languages in evaluation metrics that our work covers. Section 3 discusses how we create a corpus. Blah, blah, blah. And this new speech encoder, modeling techniques. In section 4 and section 5, evals. Okay. Okay. In section 7, social impact. Standard stuff. Okay. I'm deliberately going through the whole paper, by the way. Like usually when I'm really in a hurry and I just want to pick up the most important pieces, I just go through the main parts of the paper. I wouldn't be reading introductions like this. This is more of an experiment, like getting used to streaming, seeing how this goes, and then later we're gonna be just focused on actually replicating all of this. Let's see some of this state-of-the-art baseline models and how they compare with SeamlessM4T. I see a question in the chat. I have a weird unrelated question. What sort of research exists in solving AI problems on constrained resources? I'm thinking in particular in terms of model that are small. I mean, one repo that pops onto mind is GGML from this Bulgarian developer. Those guys are trying to basically enable you to run these large language models on edge devices. And when I say edge, I mean even Mac laptops and Raspberry Pis and whatnot. But if you think even lower than that, like there is obviously a lot of similar research directions that do like quantization, pruning, all of that is relevant, distillation, all of that is relevant to minifying the models and running them on the edge. But like, yeah, let's not digress because this is gonna be a long paper. If you have any questions related to the paper, shoot. Okay. So we have the audio poem, 8 billion parameters. As you can see, most of them don't cover all of these 5 categories. And this mostly just specifies the sizes of these models. So they have here the NLLB, 600 million to 3.3B. They did not include the 54 billion model for some reason. No worries, you're welcome. Whisper medium, okay, the large version has 1.6B. MMS is this massive multilingual speech or something, previous baseline that has done the ASR category, basically, again, automated speech recognition going from speech to text. And this work here, as you can see, covers all of these different categories. Here you can see from English to only 35 languages. Still super cool. Okay, guys, let's go to section 2. I think we're gonna get faster and faster as this stream advances. Why prioritize speech in machine translation? Okay. Speech is not just spoken text. The two modalities can differ in grammar, registers, and morphology. I'm not exactly sure what this means. If anybody knows, feel free to point down in the chat. What is register in the context of speech? That's what I'm confused about. Okay, possessing prosodic and expressive parameters unmatchable by text. Of course, you can transfer emotions, sarcasm. There is obviously much more information in the speech signal than in the textual signal. That much is clear. Okay. Why do they write stories in research papers? Yeah, because this is a longer paper. Let's just kind of skim through this part. Two versions of a paper, yeah. text-based communication is perceived as more impersonal. Makes sense? I definitely feel this. It's definitely much different when you speak with somebody in person as opposed to just getting comments on social media. It doesn't feel personal, especially when it's not personalized. Obviously, there is a spectrum there, right? Like some people just use ChatGPT to automatically reply. Some people actually take some effort and say some meaningful information. Interesting is seeing another person did not make individuals feel more connected than if they just had spoken with their partners. This is an interesting insight. This is probably why this social media application, was it called Clubhouse, works. People, like, speech is just very intimate. You can hear a lot of emotions and everything through speech, right? Okay, let's go to inclusion and accessibility section. Yeah, let me just reply to Amrit here. Basically, they are trying to give there is a broad and very, very valuable research, as you can see here, around this whole, like, why is this an important problem, right? It's not just like of pragmatic nature. It's a societal, deeply important societal, like, it's not just technological problem, it's a societal issue. Okay, they mentioned here that, wow, this is a staggering number. 773 million people are not literate. They can't read, so you basically can only talk with them. So that's another reason why you want to focus on speech additionally. Although there is a lot of people who are hard of hearing, so in a world where the volume of auditory content, podcasts, audiobooks, short-form videos is on the rise, the prohibitive nature of this socio-technical gap may deprive them of experience or exchange that could be meaningful and enriching. True. Okay. Let's continue. So again, different languages have different scripts. In Serbian, we have Cyrillic, but we also use Latin. So we are one of those languages that actually have two formal scripts. And you can see Urdu can be written either in Arabic or Devanagari script, depending on where one lives, Pakistan or India. Maybe Amrit knows more about this. He certainly knows more than I do. So again, here is another reason why speech is powerful. Sometimes the speeches, there are no like such differences and everybody can understand it, whereas with scripts you basically lose one group of people who don't understand the script. Wow, in the last 1,000 years, Uzbek has changed its writing system 5 times. Urdu can be written in English as well, says Asim. Thanks. Okay, they still use Cyrillic and Latin, similarly to Serbian, although Cyrillic varies. Russian Cyrillic is not the same as Serbian Cyrillic. Cyrillic is like a category of scripts, not necessarily a single script. Yeah, so as you can see, again, you might consider this as like just corporate BS stuff, but it's really not, like, because ultimately, even though I've never been to Uzbekistan, like, you're gonna literally change like accessibility to a whole group of people in some country that's maybe foreign to you, but like it definitely matters to hear these edge cases, because it is ultimately more of an edge case. I guess most countries just have a single script, but you still want to cover all of the groups possible. Okay, let's see speech translation today here. Okay, again, they are mentioning this cascaded system that was prevalent until recently. They have their limitations. It's better to have a single system. This is all we already know from all of different areas. Like also for language, previously people have had these, and for vision, these cascaded systems, and then just giant neural nets appeared, and now people are just training systems end to end, and the network learns the features, learns the inner representations. There is the error accumulation issue with these cascaded systems, because all of the errors that ASR makes cannot be compensated for in the text to text model. You can confuse the translation there. Main mismatches. Okay. Yeah, okay. Basically a ton of issues with cascaded systems. Let's see what's happening here. So they have some examples of these two-stage cascaded systems: Whisper medium plus NLLB, Whisper large plus NLLB again, and then three-stage if you want to go back to audio. Okay. Now there are the direct speech-to-text translation models. End-to-end models that have achieved parity, blah, blah, blah. Do you lose information by changing into text modality speech, text speech? You certainly do. You certainly do. Like that's what I said by paralinguistic. If you saw that word up there, basically you lose the information about the emotions, about like there is obviously a lot of additional encoded information. You can figure out whether somebody is like joking, whether somebody is sarcastic. There is just so much additional info. in the speech, and once you go to text, you kind of, it's almost like a projection when you're doing PCA or whatnot. Like you have to lose some dimensions, you have to lose some information, and then when you try and reproject back into the original space, you're always going to have errors. So that's kind of my mental model when I think about this. Go from speech to text and text to speech. You're literally doing something like PCA, or any of that type of dimensionality reduction method might be a good way to kind of mentally visualize what's going on there when it comes to loss of information. If that makes sense, Asim. Okay, again, the issue, they only translate into English and not the other way around. But the model was tuned on CoVost2 dataset, which only covers translation from 21 languages into English. It's good always to just map slowly these words, the names of these datasets, into what they do, just to form some understanding of the terminology. So they show that weekly supervised pre-training. So basically, with a ton of compute and ton of data, you can achieve SOTA results, state-of-the-art results on ASR and speech-to-text translation. It achieved SOTA on 82 floors languages into English. So a Whisper, unfortunately, cannot be used for translation. It can only do transcription and translation into English. So AudioPalm is currently the SOTA model, outperforming Whisper in both ASR and speech-to-text. I didn't know this. Whoops. How did I do that? And why don't I see where are the pages here? What's going on? I think my Adobe Reader got updated because I don't see let me just see whether, I don't see the page count. Maybe that's even better. Okay, let's just continue. Okay, they're just mentioning some other baselines that have different approaches, like outputting spectrograms. Translatotron. Wow, what a name. Okay, we can skip these parts. Not really interesting. Okay, although the model design suggests that it can support multilingual translation of both source and target sites, its performance is only reported for translated into English again. it only supports speech to text into English. Yeah, that's one of the limitations I kind of stumbled upon with Whisper, because I wanted to do some translation. So how this whole thing for me started is I wanted to fine-tune Llama for Serbian language, and I figured out there are no good translation systems. Like DeepL does not support Serbian. Luckily, Google Translate turned out to be the best option. But like I wanted to do like Whisper, and basically first I thought that Whisper maybe even supports machine translation. That turned out not to be the case. So I was like, let's basically convert text English into like speech using some of the TTS systems, and then use Whisper to translate into Serbian. But it turned out you have to translate into English only, and that's when I realized that there is this limitation. Just see whether we skipped something here. No, we did not. Okay. Here's a couple of data sets they are using for evaluation. There is the Flores 200. So this is the one that basically is a highly curated parallel corpus for 200 languages, and I think they have over like 1,000 sentences, and they had professional translators. This was like a big project. It ran from like June to like October or something to create this data set here. A many-to-many multilingual translation benchmark for 200 languages, okay? By the way, I should have random digression. I should have put something instead of the green screen to make it a bit more enjoyable to watch. Let me just reduce this as well, so you can see the paper better. Let me know if you can see the paper, by the way, for some reason. Hopefully you can. Okay, Flores and N-way parallel speech and text dataset in 102 languages. There is the Covos 2. This one we saw. This one translates into English only, right? A large corpus covering translations from 21 languages into English and from English into 15 languages. Okay, we evaluate on the test set. And there is a CVSS, a multilingual to English speech-to-speech translation corpus. So everything goes into English here, okay? Some languages are missing. Catalan, German, Estonian, French, Italian, Mongolian, Persian, and Portuguese. The overarching goals. Okay, unifying model that covers all of these 5 categories. Let me just zoom in a bit more. Maybe it's better like this. Increasing the coverage. Yeah, this is kind of fact. There is over 7,000 languages, yet only 2 dozen, so I guess that's 24. Account for more than 50% of world-speaking population. Wow. It's a power law, clear power law. A couple of languages that basically produce the most textual footprint. And when you just focus on those languages, basically you leave out basically the rest of the world, the other 50%. all of these goals are kind of similar to what NLLB project has basically done. Okay, let's see the languages that they cover. Broadly accessible speech translation models cover anywhere between 21 to 113 source languages, depending on the wide range. But none of them can do text-to-text translation. To build a unified multimodal and multitask that can handle both speech and text as source inputs, we set our speech source language goal at 100. Okay, in table 5. So let's check out that table. Resource, let's see how they define whether the language is high resource or low resource. What did Amrit say? Any number of % of money, time, big tech spends in data collection versus computing from your experience? Well, it's very hard to quantify that and put some real numbers. Both data collections, because for what do you mean by data collection? If you already have the tools to collect the data, then I guess it's fairly quick. But to build the infrastructure for data collection, the storage, the everything, to make everything robust, to add some sort of redundancy, that infrastructure is fairly complex. Compute, on the other hand, is also super complex. So yeah, let's define what high, medium, and low is. Let's see. I think how they defined it the last time I checked was basically using Wikipedia, and depending on how many tokens you have in a Wikipedia article. For example, English Wikipedia has that many, and then let's see how they define it here. Available primary data for the speech to text into English. So high is if X is over 1,000 hours. Medium is if it's between 500 and 1,000, and low is here. So okay, this is kind of arbitrary definition. Obviously, they probably just picked up these numbers such that only a few dozen languages are in the high resource category. There is a different definition for the machine translation systems, the one with Wikipedia that I mentioned. I'm not sure the exact numbers, but it's also fairly arbitrary. Okay, so here are some of the metrics they'll be using. We're gonna briefly skim this. Basically, there are these automatic text-based metrics like blue. There is the Blazor, which is model-based. I think that the first time I saw these types of neural metrics was when I was playing with neural style transfer. So you basically just teach the models. You use the internal representations of the models to figure out whether something is of high quality or not, as opposed to just surface level statistics and matching. Okay. Okay, we can ignore these. Here is the list. So there is the language code, which is usually, well, not usually. It seems it's only 3-letter codes here. And then there is the language name. There is the family, like you have, although I would assume you can also go more fine-grained with the family. Yeah, subgroupings here. So Germanic, Balto-Slavic. Let's see whether Serbian language is supported. Nice, Serbian is supported. So Serbian language is so that's my native language. Basically, Serbian is Indo-European, Balto-Slavic. Script is Cyrillic, but we also use Latin, so that's kind of dual script language. It's a low resource language, so that means by that definition we are probably below 500 hours of Serbian speech to English, I guess. And that's it. You can see all of the languages. Let me see what this means. So this means whether it's supported or not as the target. So it's supported as the source here. Let's see what these acronyms stand for. I think they explained it somewhere up there. Okay, here it is. So we indicate whether a source language is in the speech or text modality. And we indicate whether our target language is in the speech or text modality. So for Serbian, let's see how we can interpret this table. For Serbian, basically they say they support both speech and text, but as a target, they only support text. Yep, Asim, that's right. Okay. Let's continue. So this is going to be the fun part. So seamless align. This is the data set that they created. Developing an effective multilingual and multimodal translation system like SeamlessM4T requires sizable resources across many languages and modalities. There are some bigger corpuses like this Europarl, United Nations corpus. Those are some of those publicly available parallel corpuses. But for the most part, you have to translate. You have to you have to mine for parallel corpuses, and there are also different techniques like back translation, etc., etc. A few human-created collections also involve the speech modality, like this data set. Yet no open currently matches the size of those used in initiatives like Whisper. Parallel data mining emerges as an alternative. That's something I mentioned. Mining is then performed by pairwise comparison over massive multilingual corpora, where sentences with similarity above a certain threshold are considered mutual translations. So again, let me just quickly repeat for those of you who just came to the stream. What mining does is you take a monolingual corpus of text, like take English for example, and then you take another monolingual corpus of text like German, then you encode those using certain models like I think we'll actually have one of the main guys behind this research coming to our Discord server early September. The current director of machine learning at Cohere, Niels Reimes. Basically, he is the guy behind SentenceBird and some of these ideas for actually doing these types of multilingual embedding. So the idea is you basically you align the embedding spaces of different languages, and then once you embed, like take a certain sentence from English, you embed it into the space, and then you take some sentences from German and you also embed it into that space, and then you basically look at the surrounding point around your English point to find the potential translations. And if you train your encoder properly, you'll end up being very proficient at mining new sentences and creating these parallel corpuses. So here's they mentioned laser. So laser was actually used. Laser 3.0 was used to mine data for NLLB project. And then there is this teacher-student training that was basically proposed by Niels Reimers. Or is it Niels Reimers because he's a German? Okay. So the overall workflow for the seamless align, I'm gonna see it in figure 1, probably somewhere here. I'm gonna check it out. And builds on the approach deployed in speech matrix. Starting with a large collection of raw audio, we chunked files into overlapping segments and applied speech language identification, or LID for short. On the text side, we used a sentence segmented dataset drawn from NLLB. Speech and text corpora were then projected into a common embedding space in which mining was performed to identify translation pairs with optimal segmentation. Several improvements over the original speech matrix pipeline are introduced, and improved and extended speech language identification, a novel multimodal embedding space, and increased raw audio amount totaling 4 million hours. Nice. In the current version, mining was focused on 37 target languages of the SeamlessM4T system. Scaling to all 100 languages will be explored in future iterations of our work. Okay, that's why we have only 37 languages in the table above. And yeah, if you want to go from speech to text again, only 37 languages, only quote unquote, 37 languages are supported. Let's briefly go over this diagram and see whether we can figure stuff out. So there is the raw audio here. There is some segmentation that happens. I'm not sure what segmentation means in the context of audio. Do you chunk the part of the audio that's a single language, and then once you switch to a different language, you then chunk it again? I'm not sure whether they mean what they mean by that. I think that's the case, yeah. So you can see here LID being applied, and then these different colors probably mean different languages. Yeah, and so you can see here we can now, and then whatever VIE stands for, and then you do over-segmentation. I'm not familiar with the term. So you have input segments, and then you somehow map them into the over-segmented output. And then you end up with over-segmented audio. Okay, so I guess the main point to figure out here is what is over-segmentation. If anybody knows, feel free to just type it down in the chat. Aha, nice. Thanks, Asim. Vietnamese makes sense. Makes sense. I guess what I could have done is just, we can always go back to the table here and see, yeah. So VIE stands for Vietnamese. Thanks. Okay, let's go through this part. So let me just zoom in. Language identification of raw audio is a critical component of our workflow. Incorrectly labeling speech at this stage can prevent high quality audio segments from being aligned, or worse, add noise. Obviously, we want to have high quality LID. Numerous off-the-shelf models exist. None could cover our target list of 100 languages. Aha. So MMS has been released and covers them all, but it was not available when this project started. MMS is a different project, also from Meta. Let me quickly show you this. So MMS project, Meta multi something, let's see, massively multilingual speech. So that's Meta's basically alternative to Whisper. Therefore, we trained our own model following the kappa TDNN architecture introduced here, for which an open source model trained on Vox Lingua 107 is available. And they add support for some new languages here. Okay, training. Is over-segmented individual? Just a second. Munib, I don't see your. There is a annoying emoji in my GUI, and I can't see some of your words. Is over-segmented individual sentences, phrases? We're gonna figure out what that means in a couple of minutes, I think. Let's continue here. So we first retrained a system from scratch on Vox Lingua 107 data. So let me just kind of first highlight a couple of things. Therefore, we trained our own model following this architecture. Let me just highlight this one. We'll need that information later to get to, if we need to go back to it. So they reproduced the baseline, and this system dubbed the VL107 baseline achieved a classification error rate of 5.25% on the development set at epoch 30. Comparatively, the open source model available on Hugging Face, referred to as same code and HF, yields an error rate of 7%. So they got to a better application than what is available on Hugging Face. That's cool. We finally trained our own model for 40 epochs. This required about 172 hours on 8 GPUs. So I love the part about compute, because I'm thinking deeply what compute we'll need to replicate this, obviously. And I'm still thinking how we're going to attack this, whether we should start with NLLB first and then go to the SeamlessM4T. I think that's going to be a reasonable assumption, to first start with just machine translation and then go to this project. But I think it's important for me to pick up and understand what's going on in this project before I can make the decision. A total of 70,000 hours of speech were used, with an average of 170 hours per language, ranging from 1 to 600 hours. Again, reminder, this is a model that helps you to mine and create this seamless aligned data set. Okay. The test corpus covers over 100 languages of interest and is composed of the FLIRs, blah, blah, blah. Okay. Here are some results in table 6. And this is the classical the curse of multilinguality. I think that's how it's called. We can see that the training on the additional languages slightly decreases the overall performance for the common set of languages, which is a direct consequence of the presence of a higher number of closed languages. There is a lot of things that can be said here. First of all, we know this from like Bloom, from the Big Science event. Basically, Bloom was trained on this roots dataset, which was highly multilingual dataset that they did not end up releasing, and it performed much worse on English. And as a trade-off, it supported some of these additional languages. And then what the additional piece of context here is, what the NLLB team has done is they trained this mixture of experts model, and the reasoning behind that decision was to enable these similar languages, maybe from the same language families, to be clustered, for that information to be kind of contained in separate experts. So that was kind of the underlying intuition there, like allow the model, give it enough capacity and give it multiple experts, and then you'll avoid this type of curse of multilinguality. And that turned out to be the case. Although the situation is messier, it's not like when you're dealing with, like, I don't know, Germanic languages like English.German or whatnot, that you're always picking a single expert. In reality, it's always going to be like a blur across these different experts. I think, if I recall correctly, they only use 2 when they sample experts. They pick only 2 experts for each translation. Just some additional context. So you can see here some confusions. So you can now plot some confusion matrix, and you get that Zulu is often confused with Nyanya, Igbo with Yoruba. Those are some African languages, I think, African languages. And modern standard Arabic is confused with Moroccan Arabic and Egyptian Arabic, because those are what it's called. They're not even dialects. I think formally they are called langoids or something like that. You can Google that. Like, let me show you. Langoid meaning, not wait. Langoid. I don't even know how to spell it. Languages. Let's see. Nah, I don't remember what's the spelling, but it's like, Brian just joined. What's a quick TLDR? Okay, so let me reply to those questions. So first, we are going through this M4T paper from Meta. I'm just going through the whole thing and streaming the whole process. It's gonna take some time to go through the whole paper, and it's the first time I'm streaming, so that's kind of the higher picture here is I want to basically replicate an open source NLLB model, and I also want to open source the later on probably M4T. So that's why we started the stream, and the TLDR of so far was that we are trying to here train us, like they are training a single system that allows you to go from text, to translate from text to go from speech, to translate from speech to text, from text to text, and from text to speech. So all possible directions, basically, from speech to speech as well, and do that in a single language. So that's what this model is doing. And now we're currently going through this architecture that allows you to mine for parallel data, so that you can train this system. Here is a quick diagram. We're gonna go there. We're just getting started with this. So hopefully, Brian, this gives you some context. Let me know if you got it. There is a small lag, so I'll probably see your reply in a minute or something. And what's the motivation? I didn't explain the motivation. It's because of the license. Yeah, I want to have a pure, like a true open source project, and I think it will be a great community effort. Okay. Let's see. Where did we stop? Micro and macro average for the considered LID systems. So here are just some results that they report for the language identification. So wait, am I confused here? They're actually talking about, yeah, okay, so this is just the LID. This is just the language identification baseline. This is not for mining. We'll get to the mining part a bit later. Let's go to the filtering part. While it is important to retrieve the maximum amount of data from mining, we must also ensure high quality LID labeling. Depending on the quantity of data, I'm just gonna read this for myself and just tell you the main things they're saying. Okay, so their system is called LID 100, and by adding this additional filtering, they increased the metrics a bit. but they decrease the coverage. They remove 8% of their data. And here you can see LID 100. You can see the numbers they report here. You can see it's a bit worse for the 79 languages here. But as a additional, but as a trade-off, they obviously cover more languages. So they go from 79 to 100 here. Okay, that's kind of the rationale. We don't have to go through the details of how this exactly works. They just somehow do the filtering and they get better results. Okay. So gathering raw audio and text data at scale. So on the text side, they rely on the same dataset deployed in NLLB. That's why I think we need to start with NLLB first. Because this is kind of a derivative work, if you will, expanding NLLB work to multiple modalities to speech, namely, from text only. So they start with 4 million hours of raw audio originating from a publicly available repo of crawled web data. That's important. Table 10 provides statistics on the amount of raw audio for each language. Approximately 1 million hours in this collection are in English. So you can see how skewed this is from the get-go. A single language out of 100 languages is already accounting for 10%. No, more. 1 million hours. That means 25% is in English. They duplicated the audio file URLs found in the repo, so that means there are multiple same audio files, so they've done the duplication there. They've downloaded the audio files and resampled at 16 kilohertz. Again, probably just to minify the file sizes from maybe some of them are like 48 kilohertz or whatnot. I'm not sure what are the common sampling frequencies. I think it's 44 point something or something like that. And subsequently, we filtered out the non-speech data with a bespoke audio event detection model. Let's leave a comment here. Did they release this model? Let me just make a comment for myself for later so we can figure out how this thing actually works in detail. And then audio segmentation. To perform the speech to text or speech to speech mining, it is desirable to split audio files into smaller chunks that map as closely as possible to self-contained sentences equivalent to sentences in a text corpus. Okay, makes sense. However, genuine semantic segmentation in speech is an open-ended problem. Pauses can be an integral part of a message and can naturally occur differently across languages. So yeah, so you can basically confuse a pause for, you think it's a new sentence, but it's actually the same sentence, just you're stressing out a certain word or something. I'm gonna lose my voice if I don't start drinking water. For mining purposes, it's impossible to prejudge what specific segments can maximize the overall quality of the mine pairs. We thus followed the over-segmentation approach drawn from this paper. We're gonna see how that thing works. First, we used an open voice activity detection model. Just a second, let me just see one thing. They mentioned this table 10. Let me just see. I want to quickly, before I forget, let's quickly go there. So here is a table. Let's just see the statistics of the languages. So here are the ISO codes. Are those all? Yeah, I think these are all of the languages. So here's the language, here's the amount of audio. Train from some language into English, how it compares against Whisper, some mined audio, number of hours there, total number. Okay, let's see English. I don't see English here. Is this alphabetically sorted? I hope it is. Yeah, it is. Okay. English was 1 million, right? So we would see a number popping up here. Okay, so these guys correspond to English speech paired with foreign text, foreign speech paired with English text, and foreign speech paired with English speech, respectively. So that's what EN stands for here. T is for text, S is for speech. Okay. Let's go back to the to where we stopped here. With us, okay, let's figure out how this over-segmentation thingy works. So they follow the over-segmentation approach drawn from this paper. First, we used an open voice activity detection model, VAD, to split audio files into shorter segments. Subsequently, our speech LID model was used on each file. Finally, we created several possible overlapping splits of each segment and left the choice of the optimal split to the mining algorithm described in the next section. This over-segmentation strategy roughly octuples the number of potential segments considered. Okay. So let's see this again. I think this is important. We'll slowly form like a understanding of how this works. First, we use an open VAD model to split the files into shorter segments. Then they use the LID on each file, and then we created several possible overlapping splits of each segment and left the choice of the optimal split to the mining algorithm. Got it. Okay, and they octuple the number of potential segments considered. So how I understood it is they first, again, roughly break the audio file on like pauses. So now you have smaller chunks. Then you do the LID, you figure out what's the language, and then what you do is you create overlapping splits of each of those segments. So if I understand, they now additionally chunk that segment there to get more data points. We can also quickly skim. Let's see whether this paper here, so we are at page 19. Let's see whether this paper here has some good chart or something. Let me open it up. Okay, that link is broken, so let me just try and search it directly, see whether we can find an archive link. Is this the one? No, this is speech matrix. Is that the same thing? Multimodal and multilingual embeddings. No, that's not the same thing, I think. Let's just see. Laser. Okay. Okay, I think this is what they refer to. I think I got it correctly. So you can see here they create multiple segments that overlap, and then they let, you can see 1, 2, 3, 4, 5 segments here, and then 9 additional ones. So you can basically take a segment like this, do this type of logic, and you end up with 9 segments. In the case of the paper, we are covering 8 segments. So that's why they said they octupled it, if that's a word. Just a second. Did you guys lose me? How are you? Is anybody here still from the beginning of the stream? That would be incredible. I see 15-ish people now. It's been going up and down from 15 to 25, mostly. Let's just see. Nope, there are no other diagrams. Let's just see whether they say something smart here. Nope, they don't mention the over-segmentation here. They don't call it the over-segmentation paper. Sorry for uncontrolled zooming and zooming out. So over-segmentation. Again, they are referring to this paper. So I think that was the gist of the idea. Basically, we saw the diagram. Let's go back to page 18. So we are here. So now let's go through the speech mining part. Let me just go quickly grab some water. Maybe we can make a small break, like 1 minute, 2 minutes, and I'll be back in a sec. Okay guys, I'm back. Grabbed some water. Speech mining. Let's see how much we can get done over the next hour. I think we can wrap it up quickly. So speech mining. The overall workflow of our mining process is shown in figure 2. Okay, here is the mining approach. First, we trained encoders for text and speech. These are then used to project both modalities into a joint embedding space. Okay. We then mine speech segments against text sentences or speech segments in other languages to create large amounts of S2TT and S2ST pairs. These corpora are subsequently combined with other resources to train the SeamlessM4T model. Okay, got it. Basically, they are agnostic to the modality as far as I understand. So basically, you don't care whether your point in the embedding space is a text or audio file. You find a piece of text, for example, and then you find the surrounding points, which are audios, and that's how you create the data set for I guess speech to text and text to speech. And similarly, if you want to mine for audio data, parallel audio data sets, then what you do is you find an audio point and you find surrounding audio points as well from a target language, and that's how you basically mine data for that particular speech to speech data set. So we developed a novel sentence embedding space named Sentence Level Multimodal and Language Agnostic Representations. In short, Sonar. So that's this model here. Sonar substantially outperforms the previous laser space. It follows the same two-step approach. We first trained a text embedding space and then relied on a teacher-student training strategy to extend it to the speech modality. Similar to laser, the initial text Sonar space uses an encoder-decoder architecture but is based on the NLLB 1.3b model, capable of translating across 200 languages. Okay. We replaced the intermediate representation with a fixed size vector using mean pooling. Okay. The decoder thus attends to a single vector. This is then fine-tuned using all of NLLB's text-to-text training data, and we explored several training objectives. A detailed ablation can be found in this paper. This yields a powerful, massively multilingual sentence representation that can be decoded into all 200 languages of the NLLB project. Figure 3 provides an illustration of the Sonar architecture, and Table 8 summarizes the translation. Okay, let's kind of see first the Sonar part. So we have the segmented text from NLLB. So this is pieces of text. This is the over-segmented audio. We saw how we process the audio data to get to this configuration here. And then they have the Sonar speech encoders, the Sonar text encoders, and they have the shared multilingual and multimodal embedding space. And then you basically align. So here you can see you align Arabic audio with English text. And you here align English audio with Vietnamese text. So this is speech to text data. And you also collect here, you can see speech to speech data. That's how you basically mine for this type of data. And then you use that mine data later together with some public corpuses that falls, I guess, under the other resources box here. And basically that's the SeamlessM4T. Okay. Average performance on floors. Sonar. Higher is better here. You can see it's not as good as NLLB. Again, here because you're now additionally supporting multiple modalities, you do expect to be a bit worse than a model that's only focusing on text like NLLB 1.3b. Yeah. Some regression did happen. And then here is the Sonar architecture. Basically, we have the speech encoder, we have the multilingual speech, and then you embed that, and then you have the text encoder, you embed that. This is initialized with the NLLB model. So again, that's why we have to start with NLLB to replicate this project. And then initialized, so the text decoder is initialized with the 1B NLLB decoder. Okay. Are they trained contrastively to maximize cosine similarity, similar to clip? That's a good question. Let me just think. I didn't see any mention of how they were trained, but like I think from the previous research I read from Niels and others, you do use a contrastive approach. You basically have, and you try and do like hard mining as well, and so you have basically these large batches of single example and then all of the negatives, and then you create the larger the batch the better, because then you basically, your goal is to put the similar pairs closer in the embedding space and push away the negatives as much as possible. So yeah, I think all of these are trained contrastively, and they kind of assume that knowledge from previous work. That's my understanding as well. That's a good question. Okay. Let's continue. Let's see the evaluation for mining. Pure translation performance. We observed that the